Linear inequalities in two variables. So the main thing we need to remember about linear inequalities is that if you divide or multiply by a negative, you have to flip the sign. That's because when I divide both sides by a negative or multiply, what I do is I change the signs of the original equation. If it's negative, it becomes positive. If it's positive, it becomes negative. And that makes the inequality symbol false. You must flip it if you divide or multiply by a negative. So that's the first thing. The second thing is we now have two variables. And as we do these questions, in the back of our minds, we're always thinking y equal mx plus b. Now, it's going to be less than or greater than or less than or equal to or greater than or equal to, but mx plus b is what we're shooting for. We're going to get y by itself, and we'll grab the slope and the intercept and graph it. Now, keep in mind, if I say y is less than 1/3 x plus 2, then it must be less than. So all the equal ones, which is what I'd normally graph, a straight line, will not work. If there's an equal to on the inequality symbol, then the line would be solid because I'm shading solutions. An equal means those points would work, and it's a solid line identifying that they work. It's just like when I graph on a line, number line, and I do the open circle when it's less than or greater than, and I fill in the circle when there's an equal to. It's the same exact thing. If it's a solid line, that means I'm going to have an equal to. If it's a dashed line, then there isn't an equal to. So in this example I'm going to do, there is no equal. So my line will be dashed. Y is less than 1/3 x plus 2. My slope is a third. My y-intercept is 2. So I'm going to go to 2 and put a point, because that's the y-intercept. And I'm going to go up 1 and over 3. Up 1 over 3. Keep in mind a slope of 1/3 is the same thing as -1 over -3, because when you divide, two negatives make a positive. So instead of going up +1 and over +3, I could go rise -1, go down, and then go left -3, run -3, rise -1, run -3. If there'd been an equal to, I'd have a solid line, but because there's no equal to, my line is dashed. And now I'm going to look for which side of the line do I shade, because it's always going to be half of the coordinate plane. Well, what they teach in books is for you to grab a point. A real simple one is 0, 0, the origin. Is 0 less than 1/3 x times 0 plus 2? In other words, is 0 less than 2? Yes. That tells you it's going to be this half of the coordinate plane. However, I can tell just by looking. I'm looking for numbers that are less than. Think of the y-axis as a number line. All the less than ones are down here because those are the numbers less than 2. Just think of the y-axis as a number line. The greater than numbers are above and the less than numbers are below. And since this was less than, I was shading that side of the line. If my equation had been 2x minus 3y is less than 12, I would get y by itself to find the slope and intercept. I'd subtract 2x from both sides. I don't flip the sign when I subtract or add. Negative 3y is less than negative 2x plus 12. Now I'll divide everything by negative 3. I'm dividing by a negative. That means all the signs are going to change, which forces me to flip the sign. So y will be greater than 2/3 x. Notice the two negatives make a positive, minus 4. So I'll go down to -4 and put a point. That's my intercept, my b. The slope is up 2 over 1, 2, 3, up 2 over 1, 2, 3. 2 over 3 is the same thing as -2 over -3, because two negatives make a positive. So I could go down 2, rise -2, and run -3 to the left. 1, 2, 3. Down 2 over 1, 2, 3. Now let's put an equal to on this one for variety. Since it's equal, I would draw a straight line. I'm trying here. And since it's greater than, think of the y-axis like a number line. Here I am at -4. The greater ones are going to be above on the number line. So that means this side of the equation is what I am shading. Every point over there, if I plug it in, will make that equation true. Last thing I want to look at is an equation like y is greater than -2 or x is less than 1. This one, the top one here, we can think as y is greater than 0x minus 2. In other words, the slope is 0. Slope of 0 is horizontal, like the floor. Think of how you spell floor. Think of those O's as zeros. The floor has slope 0. It's horizontal. So at -2, I'm going to have a horizontal line. Because there's no equal to, it would be a dashed line. Those don't work. They don't make the equation true. And I'm looking for numbers that are greater than -2. Again, we're talking about y. Think of the y-axis. Here I am at -2. Every number above is going to work because they're all going to be greater. So this is what I'm going to shade. This next one, let's make x is less than or equal to 1. To graph x is less than or equal to 1, I'm remembering that that's really x plus 0y is less than or equal to 1. Notice that if I tried to solve for y, I would at some point have to divide by 0, which you can't do. That's because the slope in this case is undefined. That's a clue. But you could make a table and think of that as an equal graph. Anything you plug in for y, 1, 2, 3, they're always going to get multiplied by 0 and be gone, and x will always be 1. So 1, 1, 1, 2, 1, 3. Every number on this line has an x of 1. Down here, I'm at 1, -6. Up here, I'm at 1, 4. Everywhere on that line, x is 1. Now, I want the ones that are x is less than or equal to 1. Well, the equal ones are the line itself, so that we're good there. That works because of the equal to. Where are the numbers less than or equal to 1? I'm looking at the x-axis now. That's the only variable I have. So on the x-axis, the less numbers are this direction, which means everything over here, those are the points that would make this equation true. Let's look at some examples from your assignment. Here we have y is greater than 0x plus 2. Slope is 0, it's flat like the floor, it's horizontal. Goes through 2, and it's a dashed line because there's no equal to. I want the ones greater. Well, this is a y. I'm looking at the y-axis. Looking at numbers on the y-axis, the ones that are greater are up here. So everything on this side of our line would make this equation true. X is less than or equal to -3. That's really x plus 0y is less than or equal to -3. If I were to make a table, x, y, any y values I plugged in would become 0 because I multiply by 0, and x will always be -3 every single time. -3, 1, -3, 2, -3, 3. You can see that every point on this line, notice there's an equal to. So every point in this line is going to work because there's an equal to. The numbers less than, I'm looking at the x-axis because my equation is an x equation. The numbers less than where I'm at -3 are this direction. So I'm shading this part of my line. Everything over there makes that equation true. Here I have y is less than 2/3 x minus 3. There's my slope of 2/3, and there's my intercept of -3. y is by itself, it's mx plus b. So I'm going to go to -3 and put a point, and the slope is rise 2 and run 3, positive 2 and positive 3. So here I am. There's no equal to, so the ones on the line where the equal points are don't work. So I'm going to do a dashed line. Now, when you do this in WAMAP, and I'm mentioning this now, you probably already figured this out by now, you got to choose the dotted line, and then you basically click on which side of the line you shade. Well, it's less than, and this is a y equation. I'm looking at the y-axis, thinking of the y-axis like a number line. All the ones down here are less than -3 on the y-axis, so this is the part that I shade. So when you draw the line in WAMAP, click on that side of the line to finish the question. Here we have one with negative slope. Y is less than -3/4 x minus 2. There's my m and my b. I'm going to go to -2 and put a point. Now it's -3/4, or you could think of it as +3/-4. Both those are the same. When you divide and have one negative, your answer is negative, so it doesn't matter if the negative is on the top or the bottom, first or second. So let's try the top one. I'm going to go -3, rise -3, that's down 3, 1, 2, 3, there I am. And run +4, 1, 2, 3, 4, and there I am. 1, 2, 3, 1, 2, 3, 4. If I do the second one, I would rise +3, 1, 2, 3, and run -4 to the left. 1, 2, 3, 4. Up 1, 2, 3, 1, 2, 3, 4. Again, there's no equal to, so this is a dashed line. So draw a dashed line through those points. So in WAMAP, make sure you choose the dashed line. Y is less than, look at the y-axis. The less than numbers are right down here. And so choose the dotted line and click on this side of the line. Those are all the ones that are less than. This equation is in mx plus b form. Now you could use intercepts to graph it. It's a nice equation for intercepts, but I'll stick with mx plus b. 4x plus 6y is greater than 12. I'll move the 4x to the other side. I have to subtract it, so the sign's going to change. Notice I don't flip the sign. It's only when you divide or multiply. 6y is greater than -4x plus 12. I'll divide by 6. Y is greater than 4/6 simplifies. It reduces. Divide both by 2 to -2/3 x plus 2. So the intercept is +2. That's my b. And the slope is -2/3, or you could say 2/-3. I'll use the top one. I'll go rise -2, down 2, and run +3, 1, 2, 3, down 2/1, 2, 3. Or I could use the second one and go up +2 and run -3. That's to the left, 1, 2, 3. Did I miscount? I believe I did. So it was up 2 and over 1, 2, 3. Up 2, 1, 2, 3. No equal to again, so our line is dashed. And we're choosing that one in WAMAP, and then we're going to shade on the, it's greater than, so look at the y-axis, greater than, all the y numbers on the y-axis that are greater than 2 are right there, so it's the upper side of the line. I intentionally chose this one because you're going to have to divide by a negative. Now let me just point out here, this equation could be simplified because every number has a common factor. In fact, at least 4. They're all divisible by 4. I could divide both sides by 4. It gives me a little nicer equation. That'd be 4x minus 5y is greater than -20. And then I can move the 4x to the other side. I'm going to get y by itself. Negative 5y is greater than negative 4x minus 20. And divide by negative 5. Look at that. I divided by a negative. So I have to flip the sign. And notice that in 4/5 there's two negatives. Negative 4 divided by negative 5. So it's going to become a positive 4/5. And negative 20 divided by negative 5 is a positive 4. Again, I flipped the sign because I divided by a negative. So the intercept is positive 4, and then the slope is up 4 over 5. 1, 2, 3, 4 over 1, 2, 3, 4, 5. But 4 over 5 is the same thing as negative 4 over negative 5 because two negatives make a positive. So I could rise negative 4. 1, 2, 3, 4, and go left, run negative 5. 1, 2, 3, 4, 5. And again, there's no equal to. You haven't had an equal to, so my line is dashed. None of the equal points work. They are not solutions. Its y is less than. Look at the y-axis. Think of it as a number line. The less than numbers are below 4. These last two examples, all you're doing is solving for y. So just practice. Now, don't work with the fractions. Eliminate the fractions. You want to find the common multiple of 2, 8, and 16. And the way to do that is take your largest number, 16, take multiples of 16, 16, 32, 48. Find the first one that 2 and 8 divide into. Well, 2 and 8 both divide into 16. So let's multiply everything by 16. That will eliminate my fractions. 2 goes into 16 8 times. 8 goes into 16 twice. The 16s cancel there. They just become 1. When you multiply by 1, nothing happens. So 8 times 7 is 56x. 2 times 9 is 18. So plus 18y is greater than or equal to negative 27. And we're going to move the x over. So 18y is greater than or equal to 56x minus 27. And we'll divide everything by 18. Remember, if you divide by a negative to flip the sign, y is greater than or equal to. Now 56 over 18 does simplify. It's at least divisible by 2. They're both even. So that would be 28 over 9x. I do not believe 28 and 9 have any common factors. No, they don't. 27 over 18, that simplifies too. They're both divisible by 3. So divide by 3, you get 9. Divide by 3, you get 6. Oh, actually, they were both divisible by 9, but we can keep going. Divide them both by 3 again, and you get 3 and 2. So notice if I took 27 divided by 9, I would get 3. If I take 18 and divide it by 9, I would get 2. So minus 3 halves. Last equation. Ooh, this is a messy one. We're going to distribute. The common error will be to forget to distribute that negative. Negative 7x. Negative 7 times 6 is negative 42x. Negative 7 times positive 2 is negative 14y is less than negative 7 minus 2y. Now I've got like terms here. I can combine them. That's negative 49x minus 14y is less than negative 7 minus 2y. Let's get the y by itself. Let's move the 49x over here and the 2y over there. So I'll add 49x to both sides, and I'll add 2y to both sides to move those to the other side. I'm getting y by itself. Got to move the x over. So if I add 2y to both sides, negative 14 becomes a negative 12y. And if I add 49x to both sides, I'm going to put that first. So plus 49x, and then I have that minus 7. And now I can divide everything by negative 12. It's a little bit messy, but I divided by negative. Don't forget to flip the sign. Y is greater than 49 over 12. 49 is 7 times 7. 7 doesn't go into 12. There's no common factors. So that's negative 49. Notice I move the negative up top. That's usually what you do. Negative 7 divided by negative 12 is plus 7/12. Messy answer, but plug it in there, you'll be good.